Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In the last chapter we dealt with measures of variability. In this one it's going to be measures of position, percentiles, quartiles, and z-scores so that we can standardize our data before putting it into a predictive model. When we talk about a position of a data item, it's relative to other data elements in that data set. So the most common measurements that we provide are going to be percentiles, quartiles, and standard scores, which are also more commonly referred to as z-scores or normalized scores. Percentiles are very straightforward. If all of the elements in the data set are ranked and ordered from smallest to largest, the values that divide those ranks are called percentiles. There are 99 percentiles. So when you look at percentile 1, P1, what you're saying is 1% of the values of the data set fall below it, 99% fall above it. And P2 is 98% fall above it, 2% fall below it, and so on. Statistical jargon. A set is a well-defined collection of objects. Each object in a set is called an element of that set. So let's see if you understand this now. Question. Assume you received a 91 out of 100 on a statistical test in school. Did you score in the 91st percentile? The answer is probably not. Percentiles measure your score relative to how many people scored below you. So the only way you could score in the 91st percentile is if 91% of the people scored below you. So if you scored better than 78% of your classmates, you would be in the 78th percentile, and so on. Very key, look at the bottom. Percentiles are a measure of how you did relative to all the other test scores. That's what a percentile represents. So now let's try this another way. Assume you received a test score in the 80th percentile. What percentage of the class scored better than you? The answer is 20% scored better than you. Another way of looking at data set by position is quartiles. It's similar where percents divided it by 100, quartiles are dividing it by 25. So it's dividing a ranked data set into Q1, Q2, and Q3 respectively as the marks of 25%, 50%, and 70%. And hopefully the calculation of this looks very familiar to you because we just did it. The calculation is the same. Q1, Q2, and Q3 is the median of the data set. Q1 is the median of all below Q2, and Q3 is the median of all above Q2. So again, this is just the interquartile range, is Q3 minus Q1. So just a review from what we did last chapter. Q2 is going to be 4.5. It's the median in between of the entire data set, which means Q1 is the median of everything below Q2, which in this case is an odd number, is 2. Q3 is a median of everything above Q2, again an odd number, so it becomes 7. Finally, the interquartile range as Q3 minus Q1 means 7 minus 2 equals 5. And the third, z-score. Well, what is it? It's a unit-free score that, regardless of the original unit of measurement, indicates how many standard deviations a score is above or below the mean of its distribution. That may sound complex, but when you look at an example, it's not too bad. The z-score is often referred to as the standard score. The calculation is quite simple, depending on whether it's a population or a sample. It's the raw score minus the mean divided by the standard deviation. The positive negative of a z-score will always match the original raw score as positive or to the right of the mean, or negative, which would be to the left of the mean. Let's look at this example. I have a test score of 95. The mean is 80 and the standard deviation is 10. Well, my z-score is going to be my score minus the mean divided by standard deviation. So 95 minus 80 divided by 10, 15 over 10, so my z-score is 1.5. So I'm 1.5 standard deviations from the mean. Also of interesting note is that the z-score does communicate extra information that's not obvious in a raw score. If the z-score is 0, you're at the mean exactly. If your z-score is negative, you are below the mean. If your z-score is positive, you are above the mean. Example. Mary receives a score of 43 on her chemistry test. The teacher tells Mary that her score is equivalent to a z-score of 2.1. So, compared to the rest of her classmates, how well did Mary do? The answer is Mary did better than most of her classmates. Since her score is above 0, and in this case 2.1 times better than the average student. So I have an example here now of a file that I've read, and I'm going to take the age of each one of the records in here and convert age into a z-score. So to do this, I'm going to use the normalizer node. Now there are different versions of this, but for right now I'm going to start with just this and attach the normalizer node to this. And I'm going to configure the normalizer node. And I don't want all the columns, so I just want to convert age. Okay? That's the only one I want to do the conversion on. And I can set a min-max normalization. There's 3 different ways I can do this. I can set it so that every one is between a range of 0 and 1. Or I can do a z-score normalization, or I could do normalization by decimal scaling. In this case, I want to do z-score to stick with our working example here. And I'm going to execute the normalizer and look at the normalized table. And you'll now see that age has been converted. And so now it represents, I can quickly and easily identify those above and below. And again, through the standard deviation, how many times above or below this person's age is at. What's often helpful, you're not going to see this for a number of chapters till we get up into looking at building things like neural networks, but the normalizer is also very good for normalizing on a min-max value. And when I execute it and look at the view that way, every age has been converted. There are a number of different statistical methods that rely on this form of values between 0 and 1. So it's very helpful. So I just wanted to point out to you that was here as part of the normalization node. So our chapter summary: percentiles break an individual data set down into 100 equal parts, with P50 being the median. Quartiles break it down into 4 equal parts at 25%, 50%, and 75%. And z-scores allow us to compute deviations from the mean. That completes this chapter of the class. Feel free to move on to the next chapter.